All right. Today we're going to be learning about 6-3 binomial radical expressions. Remember what binomial means, first of all, when we were talking about our polynomials. A binomial is going to be two terms, okay? Two terms together, whether they're sums or differences, doesn't matter, but those are binomials, two individual terms being added or subtracted together. Now, like radicals, kind of like terms, if you again remember polynomials, remember that like terms are something like 2x plus 4x because the x's, okay, have the same letter and they're raised to the same power. Also, for example, z cubed plus z cubed, that's going to be 2z cubed. You can add like terms because they have the same variable raised to the same power. Same thing with radicals. Like radicals are radical expressions that have the same index and radicand, and only like radicals can be added or subtracted. Remember we were talking about indexes and radicands. Remember when you have something like this, sorry about that, it should be an n. That's what we've been calling it so far. Remember that's the index, okay? So again, like radicals are radical expressions that have the same index and radicand. The radicand is what is inside. That is the radicand. So you got to know your terminology. So in order to add or subtract radicals, again, they have to have the same index and they have to have the same radicand. If not, they simply cannot be added, and that's just the way it goes. For example, 3 times square root of 5x minus 2 times square root of 5x. Well, square root, same radicand. Hey, how do you know it's a square root? Remember, when there's no index, there's an invisible 2. When there's no index, there's an invisible 2. So you never put the 2. No one's ever going to put the 2 for you. Just know that when there's no index, it's a square root, okay? So we have square roots, and the radicand is 5x and 5x, so these are like terms. It's like saying 3 apples minus 2 apples. You're going to have 1 apple left. Well, guess what? 3 square roots of 5x's minus 2 square roots of 5x's, you're going to have 1 square root of 5x left over, and of course, you don't need the 1 coefficient because we know that that's invisible. 6x squared times square root of 7 plus 4x times square root of 5. Those are not like radicands, so it stays the same. You cannot simplify that any further. 12 cube root of 7xy minus 8 to the 5th root of 7xy. You know, the radicands are the same, and that's tempting. But the indexes are not, so this stays the same. You cannot simplify that any further. 17 to the 5th root of 17 times the 5th root of 3x squared minus 15 times the 5th root of 3x squared. Well, you have the same index, the same radicand, so you're going to have 2 times the 5th root of 3x squared because they are like radicands. So I hope that makes sense. Again, to add and subtract radicals, they must have the same index, just like these guys had them here, the same index, and it must have the same radicand. All right, so let's go ahead and practice. What is the simplest form of each expression? Well, when you look at them, they're not going to be always easy, guys. They're going to have you simplify these to see if you can find like radicands. So we're going to have to break these down. This is a skill we know how to do already. So 12. Well, I like to think of square roots. Always use your multiplication skills to think of the biggest perfect squares that you can pull out. Because remember, in a square root or in any radical, really, you're looking for pairs or sets of 3 or sets of 4, depending on the index. This is a square root, so we're looking for pairs, sets of 2. So this is 4 times 3. Square root of 4 is 2. So you got 2 square root of 3 plus 75 is 25 times 3. So square root of 25 is 5, so I got 5 square root of 3, minus the square root of 3. Oh, square root of 3. Now we're good. Now we have like radicands. Now we have like radicals. Now we can go ahead and simplify this. 2 square root of 3 plus 5 square root of 3 is 7 square root of 3, minus the square root of 3 is 6 square root of 3. and you're good. B, 250. Well, I'm going to go ahead and break 250 into 2 times 125. Now, I know that 125, the cube root of that is 5. So I got 5 times the cube root of 2, because that's what's left over, plus, I'm going to, again, break this up, divided by 2, 2 times 27. I know that the cube root of 27 is 3. So 3 times the cube root, 3 times the cube root of 3. Oh my goodness, I'm sorry. I'm messing up here. This is 3 because the cube root of 27 is 3 times the cube root of 2 because that's my leftover. Sorry about that, guys. Minus, let's break this down to 2 times 8. Well, I know that the cube root of 8 is 2. So I've got 2 times the cube root of 2, which is my leftover. So 5 cube root of 2 plus 3 cube root of 2 is 8 cube root of 2 minus 2 cube root of 2 is 6 cube root of 2. We are done. Let's continue. Let's do a couple more examples. 14 times the square root of 20. It's going to be 14 times, let's break this down. This is 4 times 5. Well, I know that the square root of 4 is 2. So I'm going to bring this 2 on the outside, but I have this 14 here. Don't be scared of that. Just multiply the 2 to the 14. So I'm going to have 28 square root of 5. Again, let me show you how I did that. You have this 14. This 14 is being multiplied to this square root of 20. Well, this square root of 20 breaks up into 4 times 5. 5 is prime. I can't do anything with that. Square root of 4 is 2, though. So I've got 14 times 2 times the square root of 5. 14 times 2 is 28 square root of 5. So hopefully that makes sense to you guys. Minus now, so you have 28 square root of 5 minus, well, 125 is 5 times 25. Square root of 25 is 5, so bring that out, and I have a square root of 5 left over, this guy. So 28 square root of 5 minus 5 square root of 5 is 23 square root of 5. D, 4th root of 32. Again, let's break it down. 2 times 16, okay? 2 times 8, 2 times 4, and 2 times 2. Okay, actually, should have just been easier this way. I don't know what I'm thinking about. Why don't I just go, actually, no. You know what? That is the way to do it. Let's go ahead and do it this way. I've got a 4th root, so I've got 1, 2, 3, 4 2s, so that comes out as a 2, and I have 1 2 left over my 4th root, plus 48. That's going to be 2 and 24, 2 and 12, 2 and 6, 2 and 3. I got 1, 2, 3, 4 2, so that comes out as a 2, and I've got a 4th root of 3. Oh, we got a problem here. That's about as simplified as we can go because I have like indexes, but I do not have like radicands. This radicand is 2, that radicand is 3. So that would be as fully simplified as you possibly could get it. All right. Now, let's talk about multiplication. If you guys remember the FOIL method, okay, if I had something like this with polynomials, x plus 1 times x plus 2, if you remember, guys, we would FOIL. X times x is x squared. X times 2 is 2x. Plus 1 times x is x. Plus 1 times 2 is 2. And then we'd add like terms, and we get x squared plus 3x plus 2. That is the exact same mathematics we're going to use for this. But now we have to use our skills of square roots. Little hint before we do this. Remember that when you have something like the square root of x times the square root of x, when you multiply these together, the square roots cancel and you're left with x. Why? We've already seen this, but let's go over it again. If I have a square root of x times a square root of x, okay, if you remember from multiplying, the only way you can multiply the same radicals is when they have the same indexes. The radicands do not have to be the same, but the indexes do have to be the same. So the square root of x and the square root of x is going to be the square root of x squared. The square root and the 2 cancel, and you're left with x alone. So anytime you're distributing and you're multiplying, for example, a square root of 3 times a square root of 3, make your life easy and just make it 3. If you want to make it difficult, you can make this square root of 9 and then go to 3. But it's really nice to know that whenever you multiply the square root of x times the square root of x, it's going to be x. Okay? So, with that in mind, 4 times 5 is 20. Excuse me, plus 16 times the square root of 2, because 4 times 4 is 16. 2 square root of 2 times 5 is 10 square root of 2. And 2 square root of 2 times 4 square root of 2, do this smart. 2 times 4 is 8. Times square root of 2 times square root of 2 is going to just come out as a 2. Why? Because the square root of 2 times the square root of 2 equals the square root of 4. The square root of 4 is 2. So now I have 20 plus 16, and I have 16 square root of 2 and 10 square root of 2. Add like terms. 26 square root of 2 plus 36. You're done. Let's do another one. 3 times 5 is 15 plus 3 times the square root of 7 minus 5 times the square root of 7 minus 7. Because the square root of 7 times the square root of 7 is 7. So now add like terms. 15 minus 7 is going to be 8. And you have 3 square root of 7 minus 5 square root of 7. So I'm going to have negative 2 square roots of 7 plus 8. Done. 3 times 2 is 6, plus 3 times 4 square root of 5 is 12 square root of 5. Plus 2 square root of 5 times 2 is 4 square root of 5. Plus 2 times square root of 5 times 4 square root of 5 is going to be 2 times 4 is 8 times square root of 5 times square root of 5 is 5. So again, I'm going to combine like terms. I'm going to get 16 square root of 5 plus 46. Okay, when I had 2 square root of 5 plus 3 square root of 2 squared, the temptation is to distribute this. But no, that's wrong. You distribute that if this was a multiplication sign. Then yeah, when you raise a power to a power, you distribute the powers. But in this case, they're asking you to square the binomial. So what's going to happen is you're going to have 2 square root of 5 plus 3 square root of 2 times 2 square root of 5 plus 3 square root of 2. And now you're going to go ahead and FOIL. All right? 2 square root of 5 times 2 square root of 5. Remember what we've been doing already. 2 times 2 is 4 times the square root of 5 times square root of 5 is 5. Done. 2 square root of 5 times 3 square root of 2. Remember, as long as the indexes are the same, you can multiply or divide any radicals you want. So, 2 square root of 5 times 3 square root of 2. This is going to be plus 6, because 2 times 3 is 6. And then square root of 5 times square root of 2 is going to be the square root of 10. They don't cancel because they're not the same. 3 square root of 2 times 2 square root of 5 is going to give you 6 square root of 10. And then 3 square root of 2 times 3 square root of 2 is going to give you 3 times 3 is 9 times square root of 2 times square root of 2 is 2. So I've got 20 plus 18, so I've got 38 over here. And I've got 6 square root of 10 plus 6 square root of 10, so I've got 12 square root of 10 plus 38. And that is how you multiply radicals, binomial radicals. And add, yeah. Okay, now, conjugates. Last thing we got to learn. Conjugates are expressions like square root of a plus b and square root of a minus b. The only difference between conjugates is this right here, okay? They differ only in the sign of the second term. When a and b are rational numbers, the product of two radical conjugates is a rational number. Okay, that may not make sense to you, but think about it this way. We already did rationalization. We talked about rationalizing. For example, if we have x over the square root of x, I need to get rid of that square root, so what would I do? I'd multiply both top and bottom by the square root of x, giving me x square root of x over x, the cancel, and then I'd have square root of x is my final answer, okay? Because square root of x and square root of x comes out as an x. So that's how we rationalize those. That's very simple. We need conjugates to rationalize more complicated denominators. So if you think about this format, though, a square root of a plus b and the square root of a minus b. If you think about it, should remind you of difference of squares. Should remind you of difference of squares. Should remind you of a plus b times a minus b. So that's a squared minus b squared, if you remember, because the centers are going to cancel out when you do the FOIL method. So just keep the difference of squares in mind here for a second. And let's look at some examples of conjugates, and we'll learn how to work with them now in a second. Some examples of conjugates: 1 minus square root of 5 and 1 plus square root of 5. Those are conjugates because they're exactly the same terms, 1 and a 1, square root of 5, square root of 5. They only differ because one is negative, one is positive. Square root of 3 plus square root of 2 and square root of 3 minus square root of 2. Those are conjugates. Why? Because they're the same terms, but just differ in their signs. All right, so those are conjugates. Now let's see how to work with them. Let's see what happens when you multiply conjugates. Okay, have this little hint here. I already had described it very briefly, but again, remember the product of a difference of squares. A plus b times a minus b is going to equal a squared minus b squared. Again, why? Because when you distribute a squared minus ab plus ab minus b squared, you're going to get a squared. These cancel, the ab's, and then minus b squared is what you're left with. So that's a good formula to remember. So we'll do it the long way, but I'll show you the nice, easy way afterwards. The long way is going to be just distribute. 5 times 5 is 25. Then you got plus 5 square root of 7 minus 5 square root of 7 minus 7. The 5 square root of 7, the minus square root of 7, they cancel. So I'm left with 25 minus 7, which is going to be 18. That's the long way. The easy way, if you remember the form of a difference of squares, my friends, it's basically the square root of the first, which is 25, right, minus the square root of the second. Well, what's the square of the second? I'm sorry. What's the square of square root of 7? This power of 2 cancels out that radical, so you're left with 7. So again, it's the square of the first, 5 squared, minus the square of the second term. So 5 squared is 25, minus the power of 2 cancels out the radical, minus 7, so I'm left with 18. If you want to do it the long way, that's fine, but boy, it's a lot easier doing it with using this formula. For example, 6 minus square root of 12 plus 6 plus square root of 12. Easy. Square of the second, so 6 squared is 36, minus square of the second term, which is square root of 12. Square root of 12 squared is 12, so I'm left with 24. If you want to do it out the long way, you can. Okay? And we got one more. All right. Now, sometimes a denominator is a sum or a difference involving radicals. If the radical expressions are in the denominator, you can rationalize the denominator by multiplying the numerator and denominator by the conjugate of the denominator. Same concept as rationalizing when there's just one radical in the denominator, same concept. But I think it's a little bit easier because you're just simply going to multiply by the conjugate. Simply multiply by the conjugate to both the numerator and denominator. What am I talking about? Let's look at example A. 3 to the square root of 2 over square root of 5 minus square root of 2. Okay, let's multiply both top and bottom, the numerator and denominator, by the conjugate. to get rid of these radicals down here, because that's the point. I cannot have radicals in the denominator. So I'm going to multiply by radical square root of 5 plus square root of 2 over square root of 5 plus square root of 2. Literally. Now I'm going to distribute. 3 square root of 2 times square root of 5 is 3 square root of 10. Plus 3 times 1 is 3. Square root of 2 times square root of 2 is 2. So plus 6. Boom. Done there. Now, down here, we could do the long way and go square root of 5 times square root of 5, then plus square root of 5 times square root of 2, then minus square root of 2 times square root of 5, then minus square root of 2 times square root of 2. Or we could use the fact that this is very similar to a difference of squares. It is a difference of squares, but involving radicals. So the square the first term, so square the first term, that's going to be 5, minus square the second term, that's going to be 2. So I'm going to factor out a 3 from the top. I'm going to get 3 times the square root of 10 plus 2 divided by 5 minus 2 is 3. And I've got square root of 10 plus 2. I'm done. There are no radicals in the denominator. Life is good. Let's do another one. 2 square root of 7 over square root of 3 minus square root of 5. Well, go ahead and rationalize. So I'm going to multiply by square root of 3 plus square root of 5 to both top and bottom, the numerator and the denominator. I'm going to distribute. 2 square root of 7 times square root of 3 is 2 square root of 21 plus 2 square root of 7 times square root of 5 is 2 square root of 35 over. Remember, let's use our trick. This is a difference of squares, okay, but involving radicals. So square root of 3 squared is 3 minus square root of 5 squared is 5. So I'm going to factor out a 2 again. So I'm going to get 2 times square root of 21 plus square root of 35 over 2. So those cancel. So my answer is going to be square root of 21 plus square root of 35. I wish I could add those together, but I can't because they don't have like radicands, and I can't simplify those any further because there are no pairs of any numbers that come out. 2 more. Rationalized. I cannot have a radical in the denominator, so I'm going to multiply 3 plus the square root of 6 to both the numerator and the denominator. Okay, 4x times 3 is 12x plus 4x times square root of 6 is 4x times square root of 6 over first term squared is 9 minus second term squared is 6. So from the top, I'm going to go ahead and factor out. I can factor out a 4, I guess. So let's go 4, 3x plus x square root of 6. I cannot add those together. They're not like terms. Over 3. I cannot reduce anything here, so I'm done. That's my answer. Last but not least, let's go ahead and conjugate. So I've got 2 plus square root of 8 that I'm going to be multiplying to both the numerator and denominator. Let's go ahead and distribute the numerator. 1 times 2 is 2 plus square root of 8 minus 2 square roots of 8, and then negative square root of 8 plus square root of 8 is going to be minus 8. Because again, square root of 8 times square root of 8 will be 8. The square roots cancel. So I'm going to have here negative square root of 8 minus 6. Now here we can simplify this a little further, my friends. First of all, we can factor out a negative 1. So let's first do that. Square root of 8 plus 6. Now, let's see what else we can do. This square root of 8, we can break that into the 4 times 2. We know the square root of 4 is 2. So this will be negative 2 square root of 2 plus 6. We could do one more factoring of a 2. So my final answer would be negative 2 square root of 2 plus 3. All right, guys, I know you can't ask questions. I know there's some things probably that you want to see again, so go ahead and see it. That's why it's a video. I hope you understood. I tried to go as slowly as possible, and I believe in all of you. So do it. Work together in class. Don't cheat, but work together in class. God bless you, and have a great day.